Good day, my viewers. Here is Uncle Paul. I'm here to take you through the law of indices. We are going to talk more about indices today. And all these indices I've written here from number 1 to number 9, I will use to just chip in some fundamentals, some facts that we have to know in mathematics. And I believe that if you can just go through this fact, it will help you a lot in solving most of the mathematics difficulties. First one, we have the x raised to power 0. In mathematics, we use this x raised to power 0 to solve many questions, and it always help us to actually handle some points anytime we are given some indices question to answer, or any fraction question to answer, such as, look at it, this x raised to power 0 in mathematics or in indices, it give us what? X raised to power 0 give us 1. That is, any value raised to power 0 in mathematics, be it 1, be it 2, be it 3, to any figure like 1,000, 1 million, it will always equals to 1. That is, example like this. If you have 5 raised to power 0, this 5 raised to power 0 will give us what? 1. That is a fundamental we know in mathematics. And this second one, I'm going to go to number 2. X raised to power 1. In mathematics, we know that x raised to power 1 give us what? X. That is, here, that is, any number raised to power 1 will give us that number. Example, if I say 5 raised to power 1, it will also give me what? 5. Do you get that? Third one, look at this example given to us here as under this law, x raised to power minus 1. That is an exponential, what's it called? Law of indices. X raised to power minus 1 in indices, it will give us what? A reciprocal. That is 1 all over what? X. Example of this will be if I have 2 raised to power exponential negative 1, 2 raised to power minus 1. It will give us what? 1 over 2. That is a constant. That is also, if you have 1 raised to power minus 1, it will give us 1 all over 9, like that. Number 4 as well, x raised to power m times x raised to power n. In this law, it will give us x m plus what? Plus n, because it's having a what? Operational sign of what? Multiplication. Under the number 5, that one look a bit different. This one will give us what? X raised to power m minus n. The example of this one here, let me quickly give you an example of this one. If you have x raised to x what? 5 times x plus 6, it gives us what? X 5 plus what? Plus 6, which will give us what? X raised to power what? 11. That's for this number 4. And for this number 5, example of it, give us what? X, assuming I have x raised to power what? 3 divided by x power 2. It will imply x raised to power 3 minus x power minus 2. Give us what? X raised to power what? 1. I think you all get that one. You can ask questions as we are going on. So this number 6 give us what? X, because this x raised to power m, close the bracket, raised to power n. This n that we are looking outside, that we have outside, it's actually applicable to the what? To the x to power what? The m that we have inside. That is x raised to power m times what? Times m times n. Give us what? X raised to power what? M n. The example of this one is this. If I have x 2, open the bracket, close the bracket, I have 3 outside, it will give me what? X 2 times what? Times 3, which implies that what? X raised to power 6. Do you all get that? Number 7 of it. This one is also very simple in the sense that as we have this one, we can say, okay, we have x raised to power what? M. Is that clear? This one is all over, which is all under the word numerator. We can bring it to the front. Give me what? X raised to power what? N. Remember, in this number 5, it looked like that number 5. So we can also turn it to what? X raised to power what? M minus n. Actually, I've given the example under the what? What's it called? Number 5. which this one actually look like. And this number 8 as well, we have x, the x raised to power x times 1 times y, close the bracket, raised to power n. This n outside here, it's applicable to both x and y, in the sense that what? This raised to power x outside, the n outside is what? Applied to what? To x inside, also applied to what? To y as well. That is x raised to power n, I get it in, and the n outside also applicable to what? To y inside the bracket. That is y raised to power what? N. This one also, which is number 9, I get it. Actually, I've given some example for you to practice at home, but this example will actually help us in our next class that we are going to from this indices law, because we are going to apply it what clearly there. This x all over y, close bracket, raised to power n, rather. This m outside apply to what? X inside and y inside, and it goes like this: x raised to power m all over y raised to power what? This. And this number 9, we can actually turn it to what? It can, we can use the principle that we use in number 7 to what? To answer this number 9 by saying x raised to power m. If in fact, if we want to even apply this one, because the m, we have m here and we have n here in number 7, we cannot just say, okay, m, if you say x raised to power m divided by, I get me, y raised to power m, I get me, you now say, okay, m minus what? Minus m, which will give us what? 0 eventually. I get me. We cannot apply it like that. If you apply that one like that, because they are not having the same base, that is x here and x here, because we are having different base, y, x here and y here, we cannot apply it like that. Are you getting me? I'm just trying to let us see the different by which you can apply this one. And if you can apply all this principle in our subsequent topic, honestly, you won't have any difficulty in answering the what we call the indices or simplification question, or any question that actually that comes or that look like that take the form of exponential. This, all these principles I've given unto you here today, in fact, it's going to it's going to help us a lot to solve many questions. I believe with what actually I've written on board, you enjoy this class very well in our subsequent class. I get me, and I'm using this one to connect us to our next topic, because in the next topic we are going to treat all these principles that we have here. As we are moving in that topic, we'll be seeing some aspects of that question given to us to simplify, in which we are going to apply all these principles step by step, which will make our our solving of such question will be so easy, and it will help us to get that thing, all the question given to us, with ease. I believe you all of us are applying this class, and with this, what I've written on board and what I've done today, I'm charging everyone of you like the page, comment on it, and subscribe to my YouTube. You're all blessed. Take care.